common thread of our panelists is, of course, a passion for software engineering and making that software engineering, well, the software secure and also usable. And I think that's what we are going to share in the use case as well. So starting a little bit with a use case and the story we want to tell you. As you know, as computers, embedded systems, microcontrollers, PLCs are all going into the connected age, we need to protect their IP, and that becomes a priority, right? So in the context of the ransomware wave of attacks of the previous summer, you might remember, for example, that we had WannaCry and Petya and non-Petya affecting multiple industries and multiple organizations in the manufacturing, industrial manufacturing environment over a very short period of time. Security becomes very important and we cannot just ignore it anymore, right? And VMI Group, of course, is a market leader working on supplying and maintaining machines for the tire and rubber industry. And Johan will share with us how they managed to embed source code protection technology of the Wibu-Systems into the PLCs of Rockwell Automation to make sure that the IP is protected, that the fraud is limited, and that the main assets of the engineers are brought under one central control. So Johan, with that, I wanted to ask you to give us a little bit of a background of the request and how you started this journey.
Good morning, everyone. My name is Johan Korte from VMI. I'm going to tell you a little bit about VMI to understand what company we are, and then I'll go through the problems we faced and how we handled that. We are a Dutch company founded in 1945, so we have a big history. We are a division of the TKH Group, maybe known, but it's a stock exchange company. We have a global organization of about 1,600 people right now, with facilities in Europe, Asia, North and South America. I had a great company introduction video prepared, but the technology failed us, so I have to tell you what we do by myself. We make machines, especially for the rubber and tire industry. The machines we build are mainly the machines that are used to build car tires and truck tires. So those are complex machines with a lot of technology in them, a lot of axes working together, a lot of vision systems, and a lot of software. Those systems, as I said, are very complex, and we want, because we're a market leader in our field, we want to maintain our leadership and we want to protect that. So, besides the fact that we have a complex technology in our machines we want to protect, there are also new developments in this, well, we call it smart tire industry. The tire builders are also looking at new technology like measuring on the road, measuring tires, measuring wear, employing new techniques within the production facilities to become more flexible, to improve quality, to measure more, to generate more data which they can use to analyze what the tire, how the tire was built, how it is performing, what the quality is. So those demands come to us as well. We have to incorporate them into our machines. So that means we have to develop a lot of, well, new technology within our machines to incorporate that. We have an R&D department of 130 people working on that new technology, and that makes us, that differentiates us in the market, and we want to protect that IP. That's critical. Now, what we were facing was two things. First, IP theft. People were literally stealing our IP, our software, and we were confronted with unwanted changes the software that is critical for the performance of our machine. Therefore, we needed more effectively protect our IP, prevent unwanted changes, and control who has access to our software. That is quite a challenge, I can say. We use a lot of Rockwell Automation software in our machines, and we were confronted with the fact that that was accessible by other people, even though you had a password on it. So that was not enough to protect our software. So what we wanted was not to encrypt the whole project and let no one in there, like you do with copiers or fax machines or whatever. No, we wanted to encrypt parts of our software that contain our IP and that are critical. And we want to control who accesses that software. Can he only use it? Can he view it? Can he edit it? That's what we wanted to control. So we needed a secure solution that gives us full flexibility on what needs to be protected and who has access to it. We have a lot of people working with our software. We have 13 engineering departments. They all create software. We have a global service team. We have a lot of commissioning engineers who put the machines in the field that needs to use the software. We have installation partners around the world that use our software. And we have customers, and the customers, they want to change the software. They want to be able to add a new sensor or maybe change a little bit. That's a demand, so we have to give them access. That makes it even more complicated. So that's a bit of the use case for VMI. So we had a big challenge. We wanted to, first we had protected the whole software package, but we wanted to protect the smaller parts of the software and very easily control who has access to it. So, and that's where Rockwell and Wibu come in.
Thank you so much, Johan. I see some nods and some smiles in the room, which makes me believe that we probably have companies which identify themselves with this problem, probably have seen it maybe from different angles. So thank you very much. Then maybe we can move to Antoon to talk a little bit about how Rockwell thought of the request itself. And how they approached it and how they thought of getting the Wibu-Systems to help as well.
Okay, thank you, Dana. When we look at automation systems as Rockwell Automation, we look at solutions that are smart, that give us the capabilities we need to enable manufacturers like VMI to achieve their targets and to get all the intelligence out of their machines. We want them to be productive, so we want it to be very, very easy to integrate technologies. Our experience is that if we make things too complex, customers will not be able to take advantage of it. And we need security. We have over the last 6-8 years seen a tremendous focus on security. And we have completely, we have an ongoing effort working on that security for our products as well as for our customer systems. If we look at industrial Internet of Things devices, they're a critical part of every architecture we deliver. We supply controllers. In a system there are networks, a lot of network infrastructure and related. HMIs and computers are always present on the floor. There are many smart sensing devices throughout these machines. Johan mentioned cameras and of course photo eyes and drives and various other devices. So and motion control is an integral part of many of these complex machines as well. All of those devices have a lot of intelligence, and we need to get that intelligence protected, but we also need to get all the smart data out of it. So when we look at security, we really look at security as a system across the entire architecture. And that's the architecture from our point of view. Dana can tell you lots more about other aspects of security in these systems, but just looking at the automation piece, network infrastructure. 10 years ago, very few plants were connected to the internet. Today, most of our customers are connected to the internet. So we need to control access to that network. We need to be able to detect unwanted access and activities that happen in that system, and that's a whole separate group in our company that has worked closely with partners like Cisco to come up with an integrated security solution for the network. Then when we're on the network and we've been authorized, then we still want to control per user who's allowed what to do and where he's allowed to do it. So there's detailed policy management that we can apply to the systems to control who can do what where. For example, if I have a programmer, he can work at his desk or he can work at the machine. If he works at his desk, he gets access to a lot of things, but he's not allowed to do forcing on a machine. If he goes actually in line of sight of the machine, his location is different. At that moment, he is allowed to enable forces, so you can override pieces of the control system. A third element of this, of course, is content protection, where we related to viewing and editing specific pieces of the code. We'll talk more about that. And then last but not least, there's tamper detection, where we want to make sure that if unwanted changes or unauthorized changes happen in the system, maybe outside of our control, whatever, we want to be able to detect it and report it with no way to override that. So when we look specifically at IP protection, we have three priorities. We want to make sure that customers can still do all their maintenance procedures. And it must be easy to use and it must be easy to manage. We want to have focused IP protection, both on the code that we really never want to expose and on code that we want to protect from, safeguard from changes, so we can ensure that maintenance doesn't make unwanted changes in code that could cause damage to the machine. That we would typically protect in a read-only mode, because you will need it for diagnostic purposes. And then last but not least, there's execution protection, where we make sure that when customers supply a machine, so when the OEM supply a machine, and the end user cannot go and start duplicating that machine and just replicating the executable code in second and third and fourth machines, because that too has happened. And for that we have an execution protection that is a license that runs in an individual controller to prevent you from, to make sure that you're authorized to run that code in that unit. And with the license management that Johan mentioned already, we make sure that that is easily administered. So effectively, there is a policy manager, it's called Defective Dog Security, and there is a license source and execution protection mechanism where we enable you to through secure devices, control access and encryption of source code, as well as of executables, focused on both machine builders, OEMs, and end users. If we look at how that thing is practically put together, there is a web administrator who can go and control the access rights and assign different users different privileges. That can be done for the users as well as for the controllers. So we get source licenses and execution licenses. Those are managed in a web portal. And then from there we assign keys to developers, to startup and maintenance engineers, and to end users if needed. And of course, end users tend to have multiple suppliers in the plant, and it's important that those licenses can be cumulative, that you don't need to carry 10 devices to maintain 10 different machines. So the one technology that we apply allows multiple vendors to all put their activations or their licenses on that same infrastructure. And with that, I would like to, I guess I'm done, and I was going to hand over to Oliver, who can probably help us understand some of the technologies behind that.
Thank you very much, Antoon. Oliver, please tell us more about the technologies that we can use. Then we will prepare ourselves for the difficult questions.
All right. Good morning, everybody. So I will not talk about the company Wibu-Systems. So if you are interested to learn more about our company and the products, we are exhibiting at the IIC booth, just at the exit of the Congress area here. So please, after the panel, come to our booth to learn more. So today I will focus on the use cases you have learned from Johan and Antoon already. So IP protection, the first thing, so that means protection against reverse engineering, protection against counterfeiting, Then monetization, that has been mentioned as well by Antoon and Johan, is that you have different features in your machine, you have different functions that are individually protected, and then you can sell them in an individual way. You can create new business models like pay-per-use, feature on demand, and so on. You can create recurring revenues, not only a one-time sale of your machine. And very important, usability. If you implement some security measures in your solution and it's too complicated to configure or to use, people will not use it at the end. And that's also one reason why we did that, replacing the passwords, which first of all, in most cases not secure. Then in many cases, if you have different functions within your PLC code, you even need different passwords, so how to handle that. And on the other side, if a service technician is at the customer side, at the user side, frequently, many times, the technicians at the user side, they will ask the technician, I want to do that myself as well, so please provide me the password. And it's difficult for him to refuse, or they can spy it. So passwords are not secure and not convenient. That's the reason why we did that. Why at all? So there are some statistics from the German Engineering Federation. They do this study every 2 years, and it shows that the number of companies that are affected by piracy is constantly around 70%, so all the last years. So there is a demand for IP protection. And the reason, or the main source of counterfeiting is indeed reverse engineering. So disassembling the mechanical parts, duplicate them, decompiling or disassembling the software to understand it, to do it again, or if you can access to the source code, it's even easier. And its components, but also its whole machines, entire systems that are with 43% really pirated. So there is a real demand for that. So what are the involved parties? Here we have on the right side, you see the manufacturer of the controllers of the PLCs. That's Rockwell Automation in our case. Then you have the machine builder in the middle. That's VMI with the software developers that develop the software for their machines. And then there is the machine users or the factories using the VMI machines to produce the tires, and they have service technicians that also want to have access to the code in the PLC in the machine. Yes, and what is the challenge? On the one side, at VMI, at the machine builder, there are several software developers. So there is a potential source that the source code can be disclosed to somebody else. So you need to be secure that you don't have any developer who is doing bad things, or you don't have developers that know everything. And on the other side, you have the service technicians at the user side that maybe want to run their own business, so doing service by themselves, so getting access to everything, or maybe use this information for other unauthorized purposes. So the challenge is to avoid this unauthorized use. So goal is prevent unauthorized access, so that nobody who is not authorized can change something in the machine control unit in the source code and cannot disclose that to others, cannot change parameters as well. This is also a liability and warranty issue in many cases, and brand problems if the machine that is somehow tampered is then not bringing the expected outcome because somebody has changed something. And might be safety reason as well, if there are safety relevant functions that should not be changed or must not be changed at the user side from the service technicians. So they must stay closed all the time. So some kind of black box that can be used from the application in the machine but must not be changed. And doing that with passwords, we talked about that before, is very inconvenient. So storing the access rights and the cryptographic keys in small hardware devices, something like that, I don't know if you can see that, is much more convenient. They cannot be duplicated, so people cannot copy the access rights from one of these to a general purpose memory stick. That's not possible, because the heart of this is something like the chip in your passport that stores the cryptographic keys in a secure way. And additional to that it cannot be copied or duplicated, given to somebody. It also can be assigned with usage limitations, like they are valid until the end of this week, or they are valid maybe for 20 different machines and different modules for the service technician, so he don't has to keep track on many passwords. Everything is in one physical device that he can put to his keyring and easily use that. And the distribution of this access rights, that is something that also needs to be easy. Antoon showed that before on his slides, how that is done. I come back to that in the next slide. So what are the difficulties in implementing such a solution into PLCs? Number one, PLCs are a closed system. Even they are programmed in a standard language. There are different products on the market, and to provide this solution, Rockwell Automation had to integrate it in the development tools in Studio 5000, and they had to integrate it in the controllers, so that the development tools can use such a CodeMeter stick, such a token, to give access to read source code or to modify source code or specific functions, and also that the PLC itself, the controller, can do this execution protection. Therefore, it's used such a SD card in the PLC. But to be able to do that, Rockwell Automation has to integrate it into the controllers, into development tools. So on the next step, then the software developer at VMI is using the access rights stored in such a USB stick, and then on the factory side, at the machine user, the service technicians are using that to have access to the parts they are entitled to. And that is an important point to make it easy, is how to manage and distribute these usage rights, these access rights. And that can be done by somebody like a permission manager, somebody responsible at VMI to assign service technicians with the authorities or to assign developers. And that can be done without physical shipping of these devices, of course. So the USB sticks, the CodeMeter sticks, are one time at the service technician, at the developer's hands, and then the access rights can be distributed over the internet from a cloud-based system and easily assigned to somebody on the other side of the world, for example, to get the rights to do a service order in the next day. Easy, 24 hours, and easy to handle. Yeah, that's the case Antoon showed before with Rockwell Automation. You see something like a portal in the internet. It's called Content License Portal, operated by Rockwell Automation, where these access rights can be transferred over the internet, so the service technician can log in there, can update his access rights according to the orders he gets. And on the other side, the PLC, the controller, is using the SD card for the execution protection. So my three takeaways is that implementation and use of security is a must for different reasons, for IP protection, for temporal protection. Passwords are no solution. They are too complicated to use, they are not secure, and they have a bad user experience. And to make the process easy, something like implementation in the business process, easy deployment of the usage rights over the internet is important as well. Make the process easy, so that really you will get the user acceptance. So thank you very much.
Thank you very much, Oliver. Thank you, gentlemen, for all the different parts that bring this use case together. Hopefully for all of us, we managed to bring a bit of perspective around how this IP protection case has been addressed. Also how we managed to focus on reducing unauthorized access to software, but at the same time making sure that usability is at the core of the solution. And we have, I think, hopefully still about 20 minutes left for questions. So maybe following on that last thought about usability, I will abuse my position as a moderator to ask maybe you, Johan, if from a user perspective you have some lessons learned, some things that maybe you would be doing differently starting this again.
one thing we experienced was that to get usability to the level we wanted required quite some effort from the device manufacturer, Rockwell in this case, because the first, let's say, versions of protection were not usable in the sense that they were very slow. So that's one thing you must take into consideration if you are starting to encrypt or secure your software. This might, if you don't do it right, you might end up slowing things down. So you have to make sure that you test it thoroughly, use it quite extensively to understand what happens, and then make adjustments as needed. So we were not the ones to make the adjustments because we are the user. We only give experience and effects to the device manufacturer, in this case Rockwell.
So in this case we need to ask Antoon. Antoon, how did you address it once this problem was actually coming to the table?
Yeah. We actually ended up with a combination between initially implementing in our existing architecture,
yeah,
running into limitations of that architecture, and in the next generation of the product, truly addressing the fundamentals of even the compiler design to be able to properly deal with these issues.
And how does this fit in your overall strategy and in your approach towards other similar customers that you are serving?
This is a broadly used technology now. It is well understood, and we see more and more people. As Oliver mentioned, we are not only focusing on the protection of the source and the executable, but we're also allowing users to put additional licenses on that stick to look for, is this feature yes or no enabled? So you can write your code for a whole series of applications and a whole series of options, and only activate those options for which there is a key on the controller itself. So that's an additional piece of making that, improving that business case, if you will, or that monetization for our users. Yeah. Or we see, and we've heard it earlier this week, there's more and more interest in pay-per-use type delivery of machines and solutions, and having the ability to control that in the controller with only adding or expiring licenses rather than with having to load new software. Things like that is dramatically easier for our users.
Thank you, Antoon. Oliver, do you want to add anything to the monetization part and the pay-per-use? Do you see the same request from the market to increase the pay-per-use?
Yeah, we see a big increase in that request from the market, and that comes from the automation industry where we are here, but it also comes from totally different industries. If you're looking into a medical area, for example, there are, let me maybe say one example from a customer of us. They are providing computer radiography equipment for hospitals. So that's expensive equipment, a few €100,000 for this large machine. And some of the hospitals in India or in other emerging countries, they are not able to afford that investment. And with that, implementing these monetization mechanisms that can create a win-win-win situation, a win for the manufacturer of the medical device. They install the devices at a low installation fee to hospitals and then make a pure pay-per-use scheme so they can increase their quantity. The hospitals on the other side, like this, they can offer this diagnostic services they couldn't do in another way, and they pay upfront for months for usage, or they pay really for each diagnostic they make, for each picture. And for the people living in that area, it's an advantage as well. If the hospital would not have that machine, they cannot get this high quality diagnostic. But if it has it, so they need to make sure they get the money to get this diagnostic, but at least they have a chance to do that. So we see this pay-per-use, subscription-based business models more and more. And so the manufacturer of devices, of machines, they have not only a one-time revenue when selling the machine or device, but they can create recurring revenues.
Thank you so much, Oliver. Okay, maybe we can open the floor for questions from the room. I think we still have some time for that. Are there any questions based on what we have shared with you so far? Not sure if we have manufacturers in the room. I Probably we do. I would expect we do. Do you recognize some of these same challenges? Do you have any areas that you would like to know more about? I have a long list of questions, so I can go into it if no questions. Go ahead.
Sure, I have a question. I'm curious as to how we're talking about protecting IP, obviously in a controlled manner, to ensure that we know how the machine is going to be running, so that we can be sure of the overall result of the product that's going to come out of the machine. Are there systems that you guys have put in place or have the possibility to put in place that also control the code that we could add to the PLC code that's running on the machine that might in some way, you know, be nefarious to damage the machine or have a poor quality product that comes out of it?
I'll take a stab and I'll hand over to Oliver. Yeah, one of the things we certainly with products like Defective Dog Security, we allow you to lock a controller and only customers signed into your Active Directory and properly authorized in that system can even connect to the controller to begin with. So that's one step. I also mentioned we have a system called Tamper Protection, where we will diagnose a checksum of everything that's in the controller from a routine perspective, from a data perspective, and we can give you detailed diagnostics on something has happened here. We may not see it in the editor. It's amazing how sophisticated some tools have become, as we've seen already a couple of years ago with Stuxnet, which was unbelievably complex. But the idea of doing things like these checksums in the controller at runtime is one of the things to address, to detect if changes are happening in the system outside of any of the monitoring systems that we normally would have supplied or used in the past. Does that answer the question?
Okay, Oliver, anything to add, or shall we take another question?
I think we can go to another question. Maybe only one thing to add. So the system allows to handle the access rights for different parties. So with different access rights, that's important.
Yeah. So this part of managing authorization and authentication on the different devices, of course, the advantage is that you can do that in an integrated way across the different devices that you might have. So, indeed, good point, Oliver. Okay, do we have any other questions? Anyone else? Other things we could share? I see a hand over there in the back. Vaguely see it. The light is not it's not very good over here, but I somehow think I spotted a hand.
Yeah, thank you. I'm interested in device security, not necessarily the upstream security that you've talked about. What's your views on the improvement of the essential ingredient of root of trust within the device itself? For example, self-generation of keys as opposed to key injection, which would seem to me a sort of critical component, especially when you're talking about a pay-for-service model.
Shall I start? Yeah. That's why we are using a piece of secure hardware for this execution protection in the controllers as well. So inside of this piece of hardware is a chip it's a smart card chip or special security controller that is hardened against side channel attacks and that stores the cryptographic keys in a highly secure manner, so that attacks to that will be relatively hard. And using symmetric and asymmetric encryption allows on one side to make the protection against reverse engineering through symmetric encryption of the code, and on the other side using digital signed code and asymmetric cryptography to make sure that the code executed on a controller is really coming from an authorized party and has not been tampered.
And I believe your question extended also into device management, dealing with individual secure devices, or devices making sure that those are secure. For that, the ODVA recently introduced a technology called SIP security, and with that we indeed do certificate-based authentication of individual end nodes in an Ethernet IP network. That is combined with secure firmware in each of the end devices, where we can even go in and disable a lot of the functions in terms of updates. Things like that. There are only signed firmware can be downloaded into those devices, and the SIP security is meant to avoid things like man-in-the-middle attacks or device impersonation, things like that. So there's a lot of things moving in that area, and I'd say if you want to catch me after the show, we can certainly talk more about that.
And Antoon, I think just to follow up on that question, thank you. I think it was a very good question. Maybe we can think a little bit, or maybe you can share some perspectives also on the cost sharing of embedding additional layers of control. So I think we made the case and we explained how we are moving in the direction of having more options of securing either at device level or at a higher level. But the question is, what are some of the good models you've seen so far of sharing that security cost? Do you have a perspective on that?
I think right now the majority of that security cost, certainly from a device identification things, is borne by us as manufacturers of the control equipment. Yeah. We feel it's critical to enable our customers in the entertainment industry, in the utility industry, in the medical industry, various areas where this is really important to have trust in being able to use our equipment and achieving security levels. There are some minor costs in terms of adding functionality like this IP protection in the controllers, but it's not designed to be a moneymaker. It's designed to be an enabler for our customers.
Thank you, Antoon. Are there any other questions from the room? Can I ask one? I see a hand up there in the back.
Hi.
Hello.
I just want to ask is your solution security certified?
We as a company are certified to 62443 edition 1, and we're working on getting more and more products certified to 62443 edition 2. So it's an ongoing effort, but the basics are there. I'll let Oliver answer the specifics for the Wibu solution.
Yeah, in our case, so the CodeMeter dongles, the CodeMeter hardware with that security chip inside, so the whole application together with the Rockwell controller is not certified, and there might be no protection profile today. But for example, the crypto controller itself and the crypto libraries, in our case, they are certified according to common criteria, EL5+, as a part of the solution.
And to add to that, I think we see in the industry indeed more and more efforts towards certification. 62443 is one of them, which is of course extensively used right now, but all sorts of different parties in this ecosystem are going towards certification. Okay, other questions? We have more questions from the room? Maybe a question from my side, gentlemen. I'm not sure if we will have other questions. I wanted to ask you, what do you think is the next step in connecting some of the different use cases or getting to the next security maturity level? We talked about the IP use case, we talked about some of the usability. What's the next step? What are some of the things your companies are considering on the path of increased security? Anyone?
Besides the fact that we secure the controllers, so to speak, we are even considering other options like moving things from to other systems. So and to split the risk of getting a victim of IP theft or tampering. So that's one of the things that's happening. But I don't know in what way, let's say the device manufacturers are moving. I'm sure they have a vision on the future. For us, it's most important thing is just to protect what we have and be able to use it efficiently without losing much time on
editing or performance.
Thank you, Johan.
That's yeah.
Yeah, maybe one short sample from my side. So intellectual property, a lot of IP is contained in the software, in all machines and devices today, more and more. But we also see IP in data. So protection of the data, integrity protection, and IP protection becomes important as well. Think about additive manufacturing, 3D printing. All the product is described with the 3D printing data, so that requires same level of security like the software in your controller.
Yeah, and I think in general, we talked about productivity today. Many different security policies exist for different products. There's no common approach to that. So if I say where would we like to go, we'd like to see more and more consistency in how both device configuration and security configuration is managed and handled. The sub-security piece is one approach, certainly for the Internet OP networks that we as Rockwell use. But all in all, I think industry needs to come together on using fewer different ways of solving the same problem.
Indeed. And maybe just to add a perspective from the consulting advisory domain, we are normally looking across organizations trying to figure out how security can be improved in the OT space, whatever type of industrial controls system you are looking into. And we are having the same considerations and the same ideas for the future, that we need to address the different pieces together. So everything from protection to more detection and more monitoring capabilities around the security risks related to the OT space are things that we are trying to build as capabilities or to advise around. So you are, all of you, very important in figuring out how to implement additional security controls in these different pieces.
Yeah, and I would say that our decision already 10 years ago to go to standard unmodified Ethernet and be able to take advantage of a lot of the tools that exist in the IT infrastructure, also in OT, rather than developing our own tools, is a major step towards making that a reality.
Great. I think we are at the end of our time, so unless there are any burning questions, you can of course talk to us at the end of this session. We need to thank you very much for your attendance. Thank you, my panelists, for being here and for sharing your perspectives. Thank you, everyone.